So, hope that went okay for you. Do you guys have any questions on any of those? You've taken the last couple minutes to investigate. Number 3? All right. So, number 3, I'll erase the answer. We'll come back around to it. It says, write an equation of a line in slope-intercept form. You okay with that part, the slope-intercept form part?
Yeah.
Okay. Passes through the point negative 3, 5, and is perpendicular to that other line. So I've said it like a million times. I know you guys know this. I'll say it again, just for my own sake. If I'm going to find the equation of a line, I need 2 things. I need a point that's on the line and slope. So to me, the point that's on the line is a pretty obvious play here. We're just told the line we want goes through that point. Slope is not so obvious, right? We are told that our line is perpendicular to this one. And so if we can remember the relationship between perpendicular lines, this will help us getting towards our line. So do you guys know? Do you remember how perpendicular lines interact? Not the same slope, actually. That's parallel. That's parallel. Opposite and reciprocal slopes. So, Kyrie, what's the slope of the line that's up there right now? 3. So, negative 1/3 is what we want. So, based on that kind of reasoning, I want my slope to be negative 1/3. And then I always use point slope to get started because, again, I go back to the question of what do you need to have? You need a point and a slope. So I'm going to use point slope form, right? There's other ways to do it. That's just how I choose to do it. So point slope would be y minus the y coordinate equals slope times x minus the x coordinate. And of course, minus a negative is really plus a positive. And that's maybe the tricky part to this one is realizing it's really minus a negative, not just like minus. And then I would distribute that negative 1/3. So it'd be y minus 5 equals negative 1/3 x minus 1. Then I would add 5. Negative 1 plus 5 is 4. Thanks, Kyrie. Other questions on anything? So number 1 was like one of the very first things we did like back in August. Order of operations, like early September, August, somewhere in there. Really long time ago. Hope that went well for you. But I think it would be understandable if you were a little rusty, right? We've done it since then, but it's been a while since you first looked at it. Graphing a line, hopefully you're doing okay with that. And of course, number 4 is really new. We've been doing that for the last 2-3 weeks. Any questions at all from anybody? Okay, so I think it's a pretty normal week. Feel free to interrupt if you come up with something. I think we're gonna do a concept quiz sometime this week, I believe, and have a DMR at the end. So like a pretty typical week for us. But that typical week stuff will kind of fade pretty quickly as we get closer to spring break in the end. So, all right. So then one final reminder to you. We have, I guess a little bit less than 2 weeks now technically until your unit test over Unit 5. And so that means we are in the middle of retry opportunities. And so if you look back to your last couple of concept quizzes, I believe it would be, 15 and 16? Does that sound right? 15 and 16? Please be sure to be considering a retry or retries as necessary. Again, let me just remind you, that last test we took, some of the folks that did retries the most saw the biggest improvement from their retries to their test. And so I would think that a similar pattern would happen here. The more you work at it, the more you process it, the better you're going to get. So, something to think about. Any questions at all about that stuff? Okay, so I thought we'd start off at the board and do a little review and hopefully tie this in really nicely to what we did last week. So please head to the board. So please, this is all review from last week. Please try that one right there. Ready, go. For anyone that happened to be watching this video later on, this will be worthwhile. You guys have done a really outstanding job. You're remembering things pretty well. There's one thing that you struggled to forget, and I want to point that out, and we'll probably need to practice this at least one more time. I think just about everybody did and so most everybody had this step, and this was great. 2x squared plus 10x minus 72 equals 0. Some people lost the equal sign in that process. Some people feel like equals 0 is equivalent to there not being an equal sign. That is not true. The equals 0 is actually very important. So here's the step that most of us forgot. Not everybody, but certainly the majority of us forgot to factor out the GCF before you do any kind of factoring at all. The GCF was 2. So this is the step we want to focus on because we struggled the most with this. When you factor out that 2, you get something like this. Now, hopefully you used a valid method. Maybe you used a box method. Maybe you used some other method. I hope you understand, it really doesn't matter which method you use. To be honest with you, some of you are probably getting good enough to where you could just look at this and do a few numbers in your head real quick and factor it. That's okay too. I want to be really pragmatic about this. I only want you to be able to factor. And I really don't care about your technique that much. I just want it to be a good, valid technique. So, hopefully you arrived at this spot when you factored. And this is where it got interesting for a few folks. Once you have factored, you want to set each factor equal to 0. Nobody really had any issues doing this. And nobody had any issues, I don't think, really doing that. But we did have some issues with this. We're like, what do we do with the 2? Some folks wanted to throw an X in there and write this. More than one person for sure. But let's be honest, it's a 2. It's not a 2X. And so that doesn't really hold a lot of water. Hopefully you'd eventually end up at this right here and say, wow, well, x minus 4 equals 0 whenever x equals 4, right? And x plus 9 equals 0 whenever x equals negative 9. When does 2 equal 0? Never. It never does. And so this is not going to produce any kind of a solution. It would just be these other 2 factors that had variables in them that will produce a solution. So we'd get 2 of them, positive 4 and negative 9 for your 2 solutions. Okay. You guys have made a lot of progress. That's pretty good. Thank you. Why don't you return to your seats, and we'll continue, believe it or not, to work with quadratics. All right, does that 2 thing make sense? Yeah. You did a good job with those steps. Brief intro, and then I'm going to turn you loose for a few minutes. So here it is. We've been doing factoring for a long time, right? Doesn't it feel like we've been doing factoring for like the last 9 months or something like that? It's been like at least 2-3 weeks we've been doing a lot of factoring. And we will continue to do some factoring. But I do want to let you know there are going to be certain scenarios with certain quadratics in which it could be argued successfully, I think, that factoring is maybe not the very most efficient, best method. There are going to be other ways that we could solve equations like what we just did. In certain circumstances, factoring is going to be good. Other circumstances, factoring is probably going to be the least efficient, or maybe not even possible. So there might be some other possibilities. So what I'm wondering if you guys could do this, I just want you to, like I wrote the word explore here, I want you just to try to mess around with this a little bit and see what you think. My challenge to you would be this: can you solve that without factoring? Can you solve that using some other line of thinking? Then you might come up with something good, or you might not. I don't know. We'll just see. This is just an exploration. See if you can solve this. At least notice some things about this. Try to solve it without using any type of factoring. See how it all goes. And certainly we'll show you what I think is maybe the best way to solve this one here in just a minute. So maybe get with a partner. Discuss. Guys, let me show you real quick what I feel like is maybe the best and most efficient strategy on how to solve something like this equation. Check this out. I think my first step would be actually to add the 27 over to the other side. So after I've done that, I would get 3x squared equals 0 plus 27, of course, is just 27. Then I would divide both sides by 3. So dividing by 3 would get me x squared is equal to 9. And this is maybe the tricky step that you probably know what to do, but maybe you don't. I don't know. How do I get rid of the squared? Oh, that's right. That's how they undo each other. So I square root both sides.
What? I'm amazed.
It's a lot simpler than
And now listen, I think there's some tricky things to navigate here, and I want to talk about a pattern here in a second. X equals So let me ask you a question. What this is basically asking us, proposing to us, is what number squared is 9? How many numbers fill that
Or
scenario? 3 or negative 3, right? 2 of them. So x equals 3 works, or x equals negative 3 works, right? Because 3 squared is 9, because 3 times 3 is 9. And negative 3 times negative 3 is also a positive 9. So another way you could write this would be this right here, plus or minus 3. Plus or minus 3. So plus over a minus. Either one of those ways works. I guess WebAssign mostly wants this, somebody told me, but they're both good notations for sure. Okay, so the general principle, if you want to take something away from this, right here, if you or I decide to square root both sides to get rid of a squared, you got to consider both the positive and the negative versions of whatever results. Okay? I would like to ask you a couple of other questions. Let's go back to that one we did a few minutes ago at the board. It was 2x squared plus 3x minus 2, I think, equals 0. Let's compare a little bit the one we did a few minutes ago with the one we just did. How are they different? There's like one really significant difference.
One has a B.
One of them has a B, and the other one, the B is
Missing, it's 0.
missing, so it's 0. So over here, the B was 3, and over here, there was no B, so B equaled 0. Let's think about what would happen if I tried to do the same steps with the one you did at the board. If I added 2 to both sides, I'd get 2x squared plus 3x equals 2. And you see how immediately you get confused?
Yeah.
It's like, whoa, I got 2 x's over there. One of them is x squared. Golly, I don't know what to do with this, right? And the reason is, on the one we did at the board, the b wasn't 0. So if the b is 0, like what we just did, that's where this whole using the square root property makes a lot of sense. If b is not 0, like in this case, the one we did before b was 3, using the square root property is a terrible strategy. Make sense? Yes? No?
Yes.
Okay, so it's really important to know when to use what tool for the job. Let me put it like this. Would you guys agree with me that certain tools are designed for certain jobs?
Yes.
Think of it like this.
Yes.
Did you know that the maker of fine jewelry, like engagement rings and earrings and necklaces, did you know that one of the tools, of their trade is something that resembles a hammer? It's like this little, small, lightweight hammer, and they'll like tap and, change the shape of things and get it all like nicely designed. It's like a little tiny hammer, just like very light, just needs a very light touch. It makes sense, right? You're making a ring, a nice little hammer. Would you also agree that a sledgehammer is in the same vein as like a little tiny jeweler's hammer? And they're both hammers, aren't they? But isn't one intended for one job and the other intended for a totally different job? Can you imagine? Girls, someday going to get engaged, and I don't know how it all worked out with the engagement ring, but let's say you kind of got to design your own ring and you're going in to check out the jewelry maker he's making a ring or whatever, and you're like, oh, I'd love to see this, going to be cool. They get out a sledgehammer. You're going to freak out, aren't you? You're like, what kind of ring is this exactly? But if they get out the right tools, you're not going to freak out because they're using the right tool for the job. Listen, the way that you just determine which tool to use for the job here is really simple. Is there a B? If the B is 0, it might be a great idea to use square roots. If the B is not 0, maybe it's factoring. That's really how you decide. Okay, so some good steps here. Step number 1, isolate the squared quantity. Sorry, that's right in the bad spot there. Isolate the squared quantity. That'd be step 1. Step 2, square root both sides. That'll put you in a pretty good spot. Okay? So if you decide that square root property is the right tool for the job, you want to get the squared quantity all by itself, and then you'll square root both sides. Don't forget the plus minus. Give you a chance to do some more practicing. Question, though?
Can I go to the nurses real quick?
Oh, yeah, absolutely. You don't have to ask. You're good.
Okay.
You're totally good. Okay, any other questions? Okay, lovely. Let's take a look at some more examples here. Why don't you guys try this one with a partner? Armed with those steps. Step one, get the squared quantity isolated. Square root both sides. Whoa. Try this with a partner. Check each other. Listen, you all need to ask me if something I say doesn't make sense to you. So here is what I saw the vast majority of people doing as I walked around. Check this out. I saw people looking at this, and they wrote something, either one of two things. They either wrote x squared plus 16, or they wrote x squared minus 16. Both of which are, in the math world at least, egregious crimes. Okay? So let me remind you of something. Now, what I'm about to show you I don't think is the right method. But please remember, math is about understanding what the symbols mean, right? As far as the language side of math. So do you guys remember what squared means? Yeah, base times itself. So if you wanted to do this, I don't like this route that you're wanting to take here, but if you really wanted to do this, you'd have to acknowledge that x minus 4 squared is really x minus 4 times x minus 4, which is neither of those, is it? This would give you x squared minus 8x plus 16 if you use the little 2 by 2 multiplication. Correct? Now, if you did do that, we're going to bypass these because neither of these was correct interpretation of what squared means, right? Even if you were going to do this, wouldn't you still end up with this? Now, some of you did that mentally, and you distributed the 2, and so you got like this 32 in there. But even if you distributed the 2, you'd still have the 50 over there, wouldn't you? I want to let you know, it is possible. Listen, it's possible to navigate this. You could actually use this unwise method and arrive at a good answer. You could. But it would be similar to, hey, I was working on a very fine watch in my jewelry shop. Hand me the sledgehammer. You're using the wrong tool for the job. There's a much better tool. And I might, if I've got time here, I might actually show you how you could have navigated that. But before I do so, I would like to show you in a lovely green color what would have been the better method. So please check this out. Whenever you've got this scenario where you just have a single squared quantity, like x minus 4 squared, and there's no apparent b, your first step needs to be to isolate the squared quantity. Do you guys see how x minus 4 squared is the squared quantity? Is it all by itself? Is it isolated right now? What's with it? And it's 2 times, so how do you get rid of the times 2? You divide by 2. So we divide by 2. When you do that, you get x minus 4 squared equals 25. So what's so great about this? Now the squared quantity is all by itself, right? Step 2 was to square root both sides. This is what gets rid of the squared, right? So when I square root both sides, over here, I get x minus 4. I don't need the parentheses anymore. And on the right side, what's the square root of 25? 5. But whenever you square root both sides, you got to consider what? Both the positive and the negative numbers that work. So it would be plus or minus 5. And then the solving of this would finish like so. X equals 4 plus or minus 5. And then you just split it up. What's 4 plus 5? 9. What's 4 minus 5? So those are your two solutions.
That's so simple.
I agree. Now listen, I can see why you wanted to do some of the things you wanted to do. You made some errors on the way towards doing that. Let me show you this. Check this out. If there would have been another way to do this, consider you had to multiply the x minus 4 squared out. But check this out. We could have done this. We could have distributed the 2 over here. And then if I was going to keep doing the blue thing, wouldn't I have to subtract the 50 over to get to equal 0? So if I did that, I'd get 2x squared minus 16x minus 18 equals 0. And if I was just so determined to use factoring, I could actually use it here. What's the common factor? 2. All right, so 2 gets factored out. And then, believe it or not, that actually factors pretty nicely. And then you'd set each factor equal to 0, which, of course, 2 never equals 0. X minus 9 could, x plus 1 could. So you'd get, believe it or not, x equals 9, x equals negative 1. Please don't pack up. We're not done. We've got about 5 minutes left. So do you see why, in this particular case, the green method was better, wasn't it? And not only that, but we had some issues executing the blue method, namely, what does squared mean? Yeah. So I'd be very, very careful to take stock of what's going to be the best method. Whatever you do, listen, whatever you do, take careful consideration for what do the symbols even mean? Like, what does squared even mean to begin with? You've hopefully got a new insight into what squared means. Maybe some old bad habits are coming to the surface and we can take care of them. We have time for one more, I think. Yeah, we got time for one more. So why don't you guys try number 3. And I label this one practice. Put it together. So let's see if you can put it together. We'll do another day of practicing tomorrow, by the way. You don't have to have this like 100% perfectly mastered today. We'll do a lot of good, hopefully good practicing tomorrow. But for now, why don't you guys try number 3, solve. Simplify your answer completely. Notice that there is no b, right? So it means b is 0. It's a good time to use square root property eventually. Hopefully all of our work will continue to pay off when we practice again tomorrow. So please check this out. Hey, you got to understand when it's time to use a sledgehammer, when it's time to use the fine little jeweler's hammer or whatever it is. Did you notice that there's no b? There's no b. So if there's no b, then I think using the square root property could be your best bet. Step 1 is to get the squared quantity isolated. So to do that, I need to subtract a 4 from both sides. This gives me 5x squared equals 35. And then I've got to divide both sides by 5. This gives me x squared equals 7. So once I've done this, I need to get rid of the squared. How do you get rid of squared? Square root. But keep in mind, what we're basically asking ourselves is what number times itself is 7? There's always going to be 2 of those. One of them is positive and the other one is negative. And so we'd leave this as x is equal to plus or minus, positive or negative, the square root of 7. All right, that'd be it. Good job today. See ya tomorrow. Don't forget to get your packet printed if you didn't have it for today.